Okay, today we're talking about tangents to circles. I'm going to try to make these notes as quick as possible. All right, we have two theorems we need to know that are going to make tangents to circles very useful to us. If you draw a tangent line, let's call this line L, and let's label the point of tangency point B. What we need to understand is that if you have a line drawn tangent to a circle, the radius to the point of tangency is perpendicular to the tangent line. It will create a 90-degree angle. Okay, so line L is perpendicular to the radius AB. Okay, now that is only a radius drawn to the point of tangency. Obviously, if I draw a radius over here, that is not perpendicular to line L. Okay? This has a lot of implications because you understand that creating a right angle creates potentially a right triangle, and you can do all kinds of things with all these right triangles that you could draw in here. And we'll talk about that in the practice problems in a moment. The second thing we need to know is if we have a point, let's call it point B, and we draw both lines of tangency that are possible to draw to point B, let's label the points of tangency C and D, it will create congruent segments. This segment is congruent to this segment. BC would be congruent to BD. That's easy to see because what it creates is two little triangles in here. And I'm hoping you guys can see, well, all right, we have a radius drawn to the point of tangency, two of those in fact, creating right angles. Consequently, it creates right triangles. If you look at these right triangles, they share a hypotenuse, which is congruent to itself. We know these legs are congruent. So if I have this right triangle with a hypotenuse and a leg, and this right triangle with a congruent hypotenuse and a congruent leg, I have two congruent triangles by HL. So consequently, BC and BD would have to be congruent by corresponding parts. Okay? All right, let's use these two theorems. We're going to use this first theorem where we have a right angle and consequently a right triangle. We're going to use that and remind ourselves all the things we can do with right triangles. Okay? So given that AB is a tangent line to C, remember, you have right triangles. Okay, so if this this line is tangent to this circle at point B, you have a right angle here. If you have a right angle, you have a right triangle. So now you can look at this right triangle. We know this is 45. We can label that 45. And now I have two congruent sides. It's isosceles, right? And a hypotenuse. That means this side has to be 10. Okay? And consequently, the radius is half of that is 5. Okay, so BD equals 10, CB is 5. All right, this wants us to find AC. Well, if I have a tangent line and a radius to the point of tangency, I have a right angle, and so now I have a right triangle. I can do 8 squared plus 15 squared is AC squared, solving that. AC is 17. All right, again, I have a tangent. I have a radius drawn to the point of tangency, gives me a right triangle. What can I use to solve for the missing side CB? I only have one side 9. I can use trig. This is the opposite side, this is the adjacent side, so I'm using tangent. Okay. Funny, I've got a tangent here and I'm using something called tangent. I wonder if those two things are related. Okay, and I can solve for CB. These are all centimeters. Last one, again, I have a tangent. I have a radius to the point of tangency, so consequently I have a right angle and a right triangle. I can use Pythagorean theorem to solve for the entire side CA. I'm only trying to find FA though, but let's find CA first. Well, I've got a 6 and an 8, so CA has to be 10. Okay, but how do I find this little piece FA? Well, I know that this is a radius of 6, so consequently this has to be a radius of 6, leaving FA to be 4. Awesome. All right, down here at the bottom. The bottom, we're going to use this here, where I have an exterior point with 2 tangency lines giving me 2 congruent segments. Okay? So let's look at this. Look what I have. I've got that over and over again. Like here's one tangent line to the circle, another tangent line to the circle, and lastly, the third tangent line to the circle. Or I can look at it this way. Here's an exterior point with 2 tangent lines, so consequently these guys are congruent. And look at it this way. An exterior point, 2 tangent lines have to be congruent. Lastly, exterior point, 2 tangent lines, these have to be congruent. Let's see how we can use it. It's telling me AC is 18. So if AC is 18, I'm sorry. Yeah, AC is 18. Very good. CE is 30. And AF is 10. Well, AF is the only small piece they've given us. They've told us this is 10. Okay, so let's march around. If this is 10, this is congruent to it. That leaves BC to be 8, because 10 plus 8 has to equal 18. This CB has to be congruent to CD, so this must also be 8. If this whole thing is 30 and that much is 8, this piece must be 22. 8 plus 22 is 30. Finally, this is 22, so this side has to be 22 as well if they're congruent. All right, thank you very much.